In this video, I try to speedrun and ace the AMC 8, but I'm doing it in a live solve. This means that I have to explain my thoughts for every problem, and I can't go back to check previous problems. Can I get a perfect score on the AMC 8? Watch the video to find out. Also, only a small percentage of you are actually subscribed, so if you end up enjoying the video, be sure to subscribe. It's absolutely free, and you can always unsubscribe at any time. Enjoy the video.
All right, we'll start at 252. 3, 2, 1, let's start. Okay, so there's 3 cups of lemon juice, and okay, there are twice as much sugar, so that's 6 pieces of sugar, 6 cups of sugar. So, and there are 4 times as much water, which means that we have 24 cups of water. So that's E. All right. Okay, number 2, 4 friends do yard work. All right. So we want to find the difference between 40 and the average. So the average, it looks like the average is 25. So 40 minus 25, that's 15. All right. Number 3. Okay, so there are 4 strawberry plants per square foot. There are 10 strawberries per plant, and there are 6 times 8 is 48. 48 feet, which is, well, 4 times 48 is 192, times 10 is 1920, so that's D. Number 4, how many dots are in the next hexagon? So this has 1 dot, and this has plus 6 around, and this has plus 12, which means that the other one following the pattern is plus 18. So 6 plus 12 plus 18, that is 36. Plus 1 is B, 37. All right, number 5. 3/4 of a pitcher is filled with pineapple juice. Okay, equal amount into each 5 cups. So each 5 cup will have that divided by 5. So what percent is this? Well, this is 3/20, which is 15%. So that's C. Okay, number 6. Aaron, Darren, Karen, Marin, and Sharon rode in a small train. Okay, so Marin sat in the last car, so Marin sat here. Aaron sat directly behind Sharon, so A and the S are right next to each other. And Darren sat in one of the cars in front of Aaron, so it has to go over here. And at least one person sat between Karen and Darren, so Karen can't go here or here, which means that Karen goes here. Who sat in the middle car? Okay, that's Aaron. So that's A. All right, number 7. How many integers between 2020 and 2400, okay, have 4 distinct digits? Okay, well, the first digit has to be a 2, which means that the next digit has to be a 3 because it can't be a 4. So the last 2 digits are the one that matter. Well, if this one was a 4, then this could be 5, 6, 7, 8, 9, which means that there's 5 possibilities. If it was a 5, it can be 6, 7, 8, 9. So plus 4, and we see a pattern. So this is 15, C. All right. Next, number 8. Ricardo has 20 coins, okay. At least 1 penny and at least 1 nickel. What is the what is the difference in cents between the greatest possible and least possible amounts of money? Okay, so he has at least 1 penny and 1 nickel. And these other 2018 coins, the greatest would be when all of them are nickels, and the least would be when all of them are pennies. So that's a 4-cent difference times 2018. So that ends in 72, so it's C. All right, number 9. Akash's birthday cake is in the form of, okay, so there's icing on the top and the 4 side faces, but there's no icing on the bottom. How many of the small pieces will have icing on exactly 2 sides? Okay, apparently this did not print out, so let me pull up the test online. The test linked it will have all the pictures, so don't you worry about that. So it looks like number 9, number 10, number 11, and the problem statement for number 12 is all cut off. Okay. So number 9, the diagram is a 4x4 cube. So it's pretty easy to see that the top edges, like the two blocks in the edges, there are 4 of them, and the ones on the side, so times 8, those will have 2 faces of icing. And on the bottom, the corners will be the one that have 2 faces. So there are 4 corners, which means that 2 times 8 plus 4 is 20. And that would be D. All right, number 10. So we have 4 marbles, okay, and we want to display them on a shelf, but we don't want to put the S and the T next to one another. Okay, I think the easiest way to do this is by complementary counting. So let's count all the possibilities that they are together. So we have A, B, and then we have a group containing the S and the T. So there are 3 ways, or there are 3 factorial, which is 6 ways that we can rearrange these 3 groups. And there's also 2 ways that we can rearrange the S and the T, so that's 6 times 2. But we're complementary counting, so there's a total of 4 factorial, which is 24 ways. So we subtract the 12, and that's 12. So that is C. All right, number 11. So we want to find the difference between the average speeds. Okay, so we just need to find, for Naomi, she traveled 6 miles in 10 minutes. And that, we want to find the difference in miles per hour, and that is, we just multiply the 6 miles by 6, so that's 36 miles per hour. For Maya, she also traveled 6 miles, but she did it in 30 minutes. So instead, we just multiply by 2, so that's 12 miles per hour, which means that the difference is 36 minus 12, which is 24, and that's E. And finally 12, we can finally move back to the printed stuff. Okay, so n factorial, okay, what value of n satisfies the following equation? All right, so, well, I guess we can start with the 9 factorial, so that's 9 times blah, 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 times 1, and the 5 factorial is 5 times 4 times 3 times 2 times 1. Okay, so we can factor out a 12 from here. This is 12. And, oh yeah, the 5 times 2 is 10. So this would just be 12 times 10 factorial, which is in that form. So n would be 10, all right. Okay, and I believe that's all the ones that are cut off. Yeah, it is, all right. Okay, we can finally move back to here. Let me check that this is still recording. Yes, it is. Okay, number 13. So 60% that a sock randomly selected is purple means that it's a 40% chance that it is not purple, since we're not adding anything that's not purple. And there are 18 that are not purple, so we want 18 to be a 40% chance of happening, which means that there are 45 socks. So there are 27 purple, which means that we added 9 purple, so the answer is 9. Okay, number 14. So the average is this dashed line. It looks like it's a little bit below 5,000. And there are 20 cities. Which of the following is closest to the total population? Well, it's a little bit less than 5,000, which means that if we multiply that by 20, well, 5,000 times 20 is 100,000. So it's a little bit less than 100,000, which means that it's probably D. All right. Number 15, suppose 15%. Okay, so the trick to solving this type of problem is we just set x equals 10. I mean, not x equals 10, x equals 100. So what this means is that 15% of x, that's just 15. And, well, 15% or 15 is 20% of what number? Well, that's 75. So that means y would be 75% of x. All right, number 16. Okay, total is 47, and it's from 1 to 6. That's the digit represented by B. Okay, so when we add up the 5 sums for each line, we're going to get 47. Okay, 1 line, 2 line. Okay. Oh, okay. So for each of these points, instead of looking at the lines, we can look at the points. So for each of these points, for most of them, there's only 2 lines passing through them, but for B, there are 3. So if we subtract the sum of all these points, which we know is 21, because that's 1 plus blah, 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 all the way to 6, if we subtract 2 times that, then we should get the value of B. So we have 47 minus 2 times 21, which is 47, minus 42, which is 5. All right, number 17. How many factors of 2020 have more than 3 factors? Okay, I think counting stuff that are more than 3 factors is pretty complicated, so let's use complementary counting again. So 2020, hopefully you remember the factorization is 2 squared times 5 times 101. Well, that means that there are 12 factors. Okay, so what are the factors, or what are the numbers that have 1, 2, or 3 factors? Well, for 1, that is just 1. For 2, that's a prime. And 3, that is just a prime squared. It can't be 2 different primes, or that would be at least 4. Yep. Okay, so 20, or not 20, 12 minus the first one, because that's 1, is 1. 12 minus the number of, or this minus the number of primes, well, there's 1, 2, 3 primes. So we subtract 3, and that minus the prime squared. Well, there's only 1 prime that has a square, so we would subtract 1 from that. And that is 12 minus 1 is 11, minus 3, okay, that is 7. That's B. Okay, rectangle ABCD is inscribed inside that. D is that. Okay, what is the area? Okay, we want to find the area of that shaded thing. Okay, so the diameter is 9 plus 16 plus 9, which is 34, which means that the radius is 17. So since the center is like halfway, we know that this is 8. And from our Pythagorean triples, hopefully you have this memorized, this is 15. So area is length times width. So 15 times 16, that's pretty easy to calculate. That's 240. All right, number 19. A number is called flippy if its digits alternate between 2 distinct digits. All right. How many 5-digit flippy numbers are divisible by 15? Okay, so divisible by 15 means it's divisible by 5 and 3. So for it to be divisible by 5, the last digit has to be either 0 or 5. Okay, but if the last digit was 0, then we'd have to have something like that. But that's not 5 digits. So the last digit has to be 5. 5, 5, 5. And that covers the 5 condition. So for the 3 condition, all the digits have to add up to a multiple of 3. And since 5 plus 5 plus 5 is 15, each of the digits have to be divisible by 3 because they have to be the same. So it has to be either 0, 3, 6, or 9. So that means that there are 4 possibilities. Okay, number 20. Oh no, another word problem. Okay, so each tree is either twice as tall or half as tall as the one to its right. Alright, well, I don't like dealing with decimal numbers, so I'm just gonna assume that hopefully all trees have a whole number of, like, heights or something. If they don't, then I guess we have to deal with these decimal points. Okay, so the average height is something 0.2, which means that it has to be 1 mod 5, the total heights of the trees, because that's the only way, like, when you divide by 5, you're going to get something 0.2. You can try it out. So, since we're assuming that none of them have decimals, then this one, the first tree, has to be 22, and the next tree after that has to be 22 as well. So this one can be either 11 or 44, so let's try both of them. 11 means this has to be 22, because again, I don't like dealing with fractions. And this 44 can either go to 22 or 88. Okay, so those are the only possibilities for no fractions. I guess we can draw these to connect the tree. Okay, so 22, 11, 22, 11, 22. That is 2 plus 1 plus 2 plus 1 plus 2, which is 8. That is not 1 mod 5. Okay, 2, 1, 2, 4, 2. 2, 1, 2, that's 5, plus 4, that's 9, and 2, that's 11. And that is 1 mod 5. All right. So we just add these up together because I think this works. Satisfies it, right? Everything is either twice as tall or half as tall as the one to the right. So we just add these together. So I think I counted 11. So since everything's multiples of 11, we just multiply 11 by 11, that's 121. 121, we take the average, we divide by 5. That's the same thing as doing this. So that's 242 over 10, which is 24.2. All right. Time to move on. Make sure I'm still recording. Okay, number 21. We want 7-step paths from P to Q, and it looks like we're just like moving checker pieces. We can only move diagonally, and we can't move outside of this board. All right, so I think 7 paths means you just, 7 steps means you just move up. So I guess we can just use recursion to solve this problem. So there's one way we can make it, or there's one way we can start, and there's one way we can go all the way only to the right, and there's one way where we can go all the way only to the left. And we can't go further than that because then we can't get there without going down, and that wastes steps. So from here, we just add up the number of ways we can get to this square. So for this, that's 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 2 is 3, 3 plus 3 is 6. This is 3 because it has to go that way. This is 4, this is 10, this is 9, this is 9, this is 19, which means that this is 28. So that's 28, all right. Okay, 22. Oh, okay, it's this pretty well-known problem. So we know the final output, but we want to know the starting value of n. Okay, I think the easiest way to go about doing this is to work backwards. So we start from 1, and we can always divide by 2, so that means we can always multiply by 2 back, but we can only reverse this step if n is odd. So this has to be, we have to only do it when, since n is odd, this is even. So we have to only do it when this is an even number and it is 1 mod 3. Okay, so we need to go back 6 steps. So from 1, we can only go to 2 because it's not even and a multiple of 3. 2, we can go to 4, and 4 is even and a multiple of 3. So 4 can either go to 1 or it can go to 8. Okay, so that's 1, 2, 3 steps, so we need 3 more steps. Okay, 1, we already know that, so we can just continue that 1. And for 8, it has to go to 16. For 16, that is even, and it is 1 more than a multiple of 3. So it can either be doubled, or we can go to 5. And 5, we have to go to 10. And 32, we have to go to 64. So that is 6 steps, right? Go from here, 1, 2, 3, 4, 5, 6, that is valid. 1, 2, 3, 4, 5, 6, valid. 1, 2, 3, 4, 5, 6, valid. Yeah, those are all valid, so we just add this up together. So 64 plus 10, that is 74, plus 8 is 82, plus 1 is 83, so that's E. All right, number 23. 5 different awards are being distributed to 3 students. Okay, and everyone receives at least 1 award. Okay, well, I've actually seen this problem before, and it's pretty relieving that the answer's on here. It's B, but basically how you do it is you count the number of ways that you can actually split these awards up. So you can either split these 3, 1, 1, 3 to 1 student and 1 to the other 2, or you can do 2, 2, 1. So for 3, 1, 1, there are 3 ways you can pick the student that has the 3, and there are 5 choose 3 ways that you can pick the awards that goes to that student. Or yeah, and then you have 2 ways to pick the award that goes to the next student. So that's 3 times 10 times 2, which is 60. And for this one, well, there are 3 ways to pick the student that only gets 1 award, and there are 5 choose 2 times 3 choose 2 ways that we can pick the award for the students that get 2 awards. So it's 3 times 10 times 3, which is 90. And 60 plus 90 is 150. All right, cool. All right, number 24. All right, so we want to find d over s. It doesn't actually give us actual lengths. So a good trick for this would just be to set s equals 1. Because then we can just find d, and that's all we have to do. So n equals 24, which means that we have n squared gray square tiles with area 1, which means that the total area is 576 for the gray region. And the gray tiles cover 64% of the large square region, which means that if we divide by 0.64, that is not a nice division. Well, this is 16 over 25, so 576 times 25 over 16. So we want to find what this is. I can't do this off the top of my head. Oh, well, 576 is 24 squared, and this is 5 over 4 squared. So that's 30 squared, which is 900. All right, so the total area is 900, which means that the side length of this is 30. So how many gaps are there? Because the total length of 30 is basically 24 of the sides with the shaded region plus 6 inches of gaps. So how many gaps? Because each of them should be the same width. Well, I think there's 24 plus 1, which is 25 gaps. So the total amount remaining for the gaps is 30 minus 24, which is 6. So 6 over 25, that's just our answer. Okay, so we circle A and move on. Okay, and number 25, finally. All right, so, okay. So I think for this, we can basically use symmetry because you can't really expect them to make us do like 5 variable equations. So since we're finding S2, let's let that be X. And that means that these are all X. What else do we not know? We don't know this, so that's Y. And since all these are squares, we know that these are all X plus Y, and so on. And this is 2x plus y. This is x plus y, this is y. All right, and we know that the rectangle is 3, 3, 2, 2 units wide, which means that x plus y plus 2x plus y, that's 3x plus 2y, is 3, 3, 2, 2. And this is 2020, so that's x plus 2y is 2020. So that means 2x is equal to 3, 3, 2, 2 minus 2020. That's 2 here, 0 here, 3 here, 1 here. So that means x is, well, that is 650 something. That is 651. All right, so that is A. All right, and that is number 25. All right, time to check our answers. Actually, before we do that, let me make sure we did everything because this did get cut off. So we ended off at 8 here, so 9, 10, 11, 12, 13. All right, it looks like we do have everything. So let's check our answers now. And we stopped at 3:15. So that's 23 minutes. All right, so let me pull up the key real quick. All right. So it is ECDBC. ECDBC. Number 6 through 10 is ACCDC. ACCDC. Number 11 through 15 is EABDC. EABDC. Numbers 16 through 20 are EBABB, so EBABB. And 21 through 25, AEBAA, AEBAA. All right, very nice. So we managed to get a perfect score. Thank you for watching, and we'll see you next time.